Assalamualaikum and very good morning. Okay, this is the tutorial 1 solid plane. Okay, this is our geometry. We have a plane, a whole plane with a thickness of 10 mm. This is the dimensions. So we will draw this in ANSYS 2023. Okay, so search your ANSYS 2023. Okay, for example here, and go to workbench. Okay, fine. Okay, it may take some time while waiting to the software. Okay, just refer back to this tutorial. Okay, dimension, it is 200, length, width is 100, and the hollow circle here located at the middle of the plate. Okay, later we will have the force acting at the side, okay, with 10,000 Newton, and also fixed at the other side. Okay, so from here, okay, while it's open, okay, I close down at the back side. Okay, this is ANSYS 2023. Okay, we'll proceed using the static structural. Double click. Okay, so you have this one. Okay, for ANSYS 2023, they have option. Okay, right click at the geometry. You will find out by default it will link to discovery geometry. Actually, we might have a few options such as space claim and also design modeler. Okay, for this class, as I mentioned earlier, so we proceed using design modeler. So just click here, design modeler geometry. It is similar to the tutorial for ANSYS 2022. Okay, so for our class, better to proceed to this one. Okay, start draw this thing. Okay, we will start at which plane we want to decide. Okay, for this case, I like to decide at plane X and Z. So by that, I choose this one, plane XZ. Okay, then go to sketching. Okay, so from here, actually there are a few options to draw the model, but for this case, I decide to use the rectangle button. Oh, before that, check your unit first. Okay, click the unit button. This is meter, change to millimeter. Okay, so proceed to the rectangular button again. Okay, check the dimension, general, so the length and the width. Okay, V1 is 200, H2 is 100. Okay, so zoom. Okay, this is the dimension. Okay, so next we should have a hollow in the middles. Okay, so click draw again, go for circle, click any space first is okay, any locations. Okay, after we draw, go to dimension again. So this is the radius. The radius for the circle is 25 to 25. Next one, we should set the dimension to so that it will be located at the middle of the plane. So click here, and also this one. Here it is 100. Okay, so next one, it is here, and here it is 50. Okay, so our hollow is located in the middle of the plate. Okay, then we proceed to extrude. click extrude button and choose the whole body. Okay, if you notice here, they change the thickness here. It is only 10 mm. Okay, refer back to the equation. Thickness given is 10 mm. Okay, design modeler change to 10 mm. Then okay, then generate. Okay, so this is your model. Okay, so next we'll proceed to the analysis or setting the loading and boundary conditions. So for that purpose, click at this workbench. Okay, click the model. Okay, double click. So the model will be directly linked to the mechanical module. Okay, it may take some time, depend on the capacity of your laptop. Okay. Okay, so this is the mechanical. Okay, you have the model. Okay, so refer back to the questions. Okay, so we have the model, complete model. Then we need to assign the materials and also meshing and also the boundary conditions. Okay, how we gonna to conduct this? Okay, just step by step, don't worry. Okay, for geometry, it is a solid already there. So for the materials, click here, it is a structural steel. Okay, our question also need to be assigned as structural steel. Okay, actually by default, it is a structural steel. Don't worry. So then we go to mesh, just click mesh, right click, and then generate mesh. Okay, so it is the auto setting, or we call it a default meshing. Okay, if you want to refine the meshing, actually you can click, then insert all the details. Okay, for example, if you want to make a sizing, okay, we want to have a smaller size. Okay, for example, this one is 1.1157 negative 2. If you want to make it 0.0005, for example. Okay, I think it is too small, maybe 0.05. Okay, we select the whole model, for example. Okay, click the button here, then apply. Okay, then we generate the mesh. Okay, so we have a more refined meshing. Okay, then for loading, you can click to the solution. Okay, static structural, go insert the fixed support first. Okay, if you notice here from the equation, our support will be at the left side, our loading will be at the right side. Okay, so return back to this one. Okay, if you want to make some adjustment setting here, you can play around with this button. Okay, just the left click. Okay, we will fix here. Okay, so how we gonna click this? Okay, find the surface here, click the surface, then apply. So it is fixed at this region. Okay, for file loading, okay, we make some adjustment here. Okay, again, right click, insert, go for force. You have force here. Okay, we have force here. Okay, so again apply, click the surface. Okay, so remember our loading will be at the x directions. Okay, so for magnitude, click here. Okay, vector, we can define for the component, give detail x, y, and z directions. Okay, so our loading will be perpendicular to this. For this case, it is the x-axis and 10,000 Newton. Okay, it is x-axis. Oh, sorry, just put the value here, 10,000. 2, 3. Selection, it is here. Okay, then apply. Okay, see. So then you have the fixed support. For better view, this is your fixed support and this is your force. Okay, so far we complete all the pre-processing and we want to proceed for solution. Okay, for the solution, so we have to identify what result we want to have. Okay, insert. So normally we will find the deformation, go for total, you can go for directional XYZ, and also we can go, normally we will find the stress, equivalent stress, bomb access, and also you might need the result of strain. For example, we can go for equivalent stress, equivalent strain. Okay, then click solve. Okay, with okay, it is still being calculated. Okay, just allow. Okay, almost finished, 98%. Okay, so it's ready, so you can clear all the results. Okay, then you will get all the findings here. Okay, and sorry, this is the scale for the deformation. This is for directional. Okay, this is equivalent stress and also inertic strain. So if you need to have other results, just pick at the analysis setting. Okay, the static structure, what result you want to have it here. Okay, sorry, solution, what the result that you are looking for. For example, if you need a maximum principal stress, minimum principal stress, you can declare it earlier. Okay, I think that's all. Good luck.